Morning, one and all. Today, we are going to see one more problem on economic load dispatch problem with the four generating units. With four generating units. Here, what we are going to do is we are going to solve this problem by using the Lambda iteration method, because Lambda iteration method is very simple method. One of my student subscriber, he asked this doubt. He got in exam. He don't know how to solve this problem. He solved partially and he don't know how to obtain the solution to the problem. So for him, I'm just doing this video. Here, determine the most economical units to be committed to supply a load of 6 megawatt. Therefore, four units, generating units with the following data are given. So C1 cost function 1, they are given as 0.8 P1 squared plus 21 P1. C2 is equal to 0.P2 squared plus 22 P2. C3 is equal to 0.5 P3 squared plus 21 P3. C4 is equal to 0.6 P4 squared plus 20 P4. If the problem is given, first, if you are going to solve by using the Lambda iteration method, first you mark what is the fuel cost coefficient, that is A1, B1, A2, B2, A3, B3, A4, B4. So it is very easy for you to solve, substitute the answer. Next, the maximum and minimum limits for each units are given as 6 megawatt and 1 megawatt respectively. Like this, the problem is asked in the exam. You need to solve like this by using the Lambda iteration method. Solution, first given, what is given in the problem? Demand, power demand as or load demand as 6 megawatt, that is PD is equal to 6 megawatt. Minimum and maximum operating limits are given as 1 megawatt less than or equal to PI less than or equal to 6 megawatt. That is given in the problem. Solving by Lambda iteration method. So, very simple. Lambda iteration method is very simple to solve answer and with less time also. So you can opt this Lambda iteration method. This is one of the important 10-mark question. They asked this question at the 10-mark question. This is one of the important 10-mark questions. So first, step number 1 to calculate the lambda. So lambda is equal to PD plus summation I is equal to 1 to n, BI divided by 2AI, the whole divided by summation I is equal to 1 to n, 1 divided by 2AI. So so four generating units are given, even though 5 generating units or 10 generating units, whatever the problem is asked, you need to substitute so here n is equal to 4. So B1 divided by 2an plus B2 divided by 2a2 plus B3 divided by 2a3 plus B4 divided by 2a4, the whole divided by 1 divided by 2a1 plus 1 divided by 2a2 plus 1 divided by 2a3 plus 1 divided by 2a4. So you need to substitute the values for B1, A1, B2, A2, B3, A3, B4, A4 in this. So just substitute this and simplify using your scientific calculator. As I said, what you need to do is you need to take the decimal as 4, round it off. You need to, after decimal, you need to take 4 digits. Okay, just calculate by your scientific calculator. We'll get the answer as 6 plus 69.125 divided by 3.2916. So after simplifying, you'll get the lambda as 22.8232. Here, step number 2, you need to calculate PGI or PI. So here PI only mentioned. So PI is equal to lambda minus BI divided by 2AA for I is equal to 1, 2, 3 and 4. Why? Because up to 4 means only 4 generating units are given in the problem. That is 4 cost function for the corresponding generating units are given in the problem. So here P1 is equal to lambda. Lambda already we calculated as 22.8232 minus B1. So B1 divided by 2A1. So here B1 21 divided by 2 into A1 is 0.8. Just substitute all this values. Just take your scientific calculator and calculate it. You'll get the answer as 1.1395 megawatt. Here, similarly, P2 is equal to 22.8232 minus this B2. B2 is 22 divided by 2 into 0.8, you will get the answer as 0.86 megawatts. Similarly, P3, you need to substitute the values, you will get the answer as 1.8232 megawatts. Similarly, P4, you need to substitute the values, you will get the answer as 2.3526 megawatt. Now you need to check for the demand. So P1, P2, P3, and P4, we got the answer like this. You just substitute it for the demand. That is nothing, that is equal to demand. That is P1 plus P2 plus P3 plus P4 is equal to PD, that is equal to 6 megawatt. While substituting this, we are getting the answer as approximately 6.0013. That is approximately equal to 6 megawatt. But even though P1, P2, P3, P4 satisfies the demand, and also you need to check the check for the minimum and maximum operating limits. That is P1 is equal to that values you need to write. Minimum and maximum operating limit given in the problem as 1 megawatt less than or equal to PA less than or equal to 6 megawatt. So you need to check for all this minimum and maximum operating limits. So while checking this, the generating units P1, P3, and P4 satisfies the minimum and maximum operating limits, but P2 violates its minimum operating limits. So you need to consider P2 as 1 megawatt. That is, if it is violate the minimum operating limits, you need to consider as a minimum operating limit value. So minimum operating limit value mentioned in the problem is 1 megawatt. So sometimes what students will do is you just calculate the demand, like approximately calculate P1, P2, P3, and you'll calculate the demand. Also it will satisfy. So students, what they will do is they will stop up to this. P1, P2, P3, P4, it satisfies the demand, and also so they will write a conclusion as P2 is not satisfying the minimum and minimum operating limits. Like that, they will conclude, they will stop the problem. If you stop up to here, you will get only 2 marks out of 10 marks. Because even though, yeah, you calculated P1, P2, P3, but the limit not satisfies, no? So if you, some students, what they will do is they will stop up to here. So they will get only less marks, 2 marks or 1 marks like that, based on the valuator. So what you need to do is you need to calculate all the generating units such that it should within the minimum and maximum operating limits also. So you need to further proceed. How to proceed? Yeah. What are the optimality condition? Optimality condition DCI divided by DPA is equal to lambda for PA minimum less than or equal to PA less than or equal to PA maximum. Then DCI divided by DPA is less than or equal to lambda for PA is equal to PA maximum. DCI divided by DPA greater than or equal to lambda for PA is equal to PA minimum. These are the 3 optimality condition already we solved in our previous classes. If not, you just go back to my previous class and search using Lambda iteration method. That video also I will give in the description or and also in the comment section. You just go and watch this Lambda iteration method, and also the optimality condition already we did it. Now you need to see whether which condition it falls, because here we consider P1 violates its minimum operating limits. Minimum operating limits means P2 is 0.686 megawatt. So it is violating its minimum operating limits. So we are considering the P2 as 1 megawatts. That is the rule. That is the Lambda iteration algorithm rule. So we consider as P2 as 1 megawatt, but you need to check. We let the value as 1 megawatt, but we need to check whether the P2 is 1 megawatt or not. So we need to go for this optimality condition. So which condition it falls now? It is falling under the minimum operating limits. Okay, because we consider the P1 as 1 megawatt. That is minimum operating limits. No, so it is falling under this condition. So this condition is DCI divided by DPI greater than or equal to lambda for PA is equal to PA minimum. So minimum value only we set the minimum value. So this condition you need to search. So here DC2 divided by DP2, by taking P2 as 1 megawatt, you need to calculate the values. So here C2, what C2 is already given is in the problem as 0.6 P2 square plus 22 P2. That is given in the from the problem. So here, by taking P2 as 1 megawatt, so here you need to differentiate this particular equation. So while differentiating, you'll get the answer as 1.2 P2 plus 22. So here P2 is equal to 1 to, by taking P2 as 1 to a megawatt. So you need to substitute P2 as 1 megawatt here. So just simplify it, you'll get the answer as 23.2. So 23.2 greater than 22.8232, because greater than this condition, this value DC2 divided by DP2 value is 23.2. That is greater than this lambda value we already calculated. Lambda value we already calculated as here as 22.8232. So here lambda value you need to substitute here. So 23.2 is greater than 23.8232. So this condition satisfied. This condition greater than or equal to, but greater than. So this condition set. Now only we are confirming P2 as 1 megawatt. So previously we are just assume the P2 as 1 megawatt, but now only this condition satisfies. So now only we are confirming P2 as 1 megawatt. Next, what is the next step? We need to calculate the new demand. So new demand is equal to, what is the formula for calculating new demand? PD new is equal to PD volt minus sum of fixed generation not satisfies the optimality limits. So PD volt, that value you are taken as 6 megawatt minus sum of fixed generation not satisfies the optimality limits, that is 1 megawatt. So 6 minus 1 is 5 megawatt. So PD new is equal to 5 megawatt. Next, you need to calculate the lambda new value. So what is the lambda new? Lambda new, same formula. Lambda new is equal to PD new plus summation I is equal to 1 to n BI divided by 2AI, the whole divided by summation I is equal to 1 to n 1 divided by 2AI. So for calculating new lambda, we need to neglect the second generating unit alone, because we already calculated P2 as 1 megawatt. So here we need to neglect only second generator alone. Okay, because I is equal to 1 up to n, no. So I is equal to 1, 3 and 4 you need to do. So here lambda new is equal to 5, that is PD new is 5 megawatt plus B1 divided by 2A1 plus B3 divided by 2A3 plus B4 divided by 2A4 divided by 1 divided by 2A1 plus 1 divided by 2A3 plus 1 divided by 2A4. So here also we neglected like second generating unit. Here also we neglected second generating unit because already we calculated P2 as 1 megawatt. Now you need to substitute all this B1 and A1, B3, A3, B4, A4, all these values you need to calculate lambda. While substituting all these values from the problem data, we are getting the answer as lambda new as 22.6948. Here now from this new lambda new value, we need to calculate PI new. PI new or PGI new is equal to lambda minus BI divided by 2AI. So lambda what? 22.6948 minus BI what? That is given from the problem. P1 means B1 divided by 2A1 given from the problem. Just substitute those values. You'll get the answer as 1.0592 megawatt. Similarly, P3 new. P3 new is also lambda value what? 22.6948 minus BA. That is B3 divided by 2A3. That substitute those values, you'll get the answer as 1.6948 megawatt. Next, P4 new. P4 new is equal to 22.6948 minus this value. B4 divided by 2A4. This values you need to substitute from the problem data. We are getting the answer as 2.2456 megawatt. You also mentioned in the comment like you got the same answers for this problem or not. So just we calculated. Now we need to write all the values here. P1 is equal to 1.0592 megawatt. P2 is equal to 1 megawatt. Already we calculated. P3 is equal to 1.6948 megawatt. Then P4 is equal to 2.2456 megawatt. So minimum and maximum operating limits is given as 1 megawatt less than or equal to PI less than 6 megawatt. Now all the generating units P1, P2, P3 are within this minimum and maximum operating limits. Now you need to write the conclusion as P1, P2, P3, and P4 satisfies the minimum and maximum operating limits, and also it satisfies the load demand. You just take your scientific calculator, just calculate it, P1 plus P2 plus P3 plus 4 P4. You are getting the approximately equal to 6 megawatts. So it satisfies the load demand P. Like this, you need to conclude the problem. So some students, what they will do is you just stop up to this. So you will not, you will get 8 marks out of 10 marks. So you need to write all the values and with the minimum and maximum operating limits, and you need to write the conclusion at the last. Like that, if you write, you will get the full 10 of 10 marks in your main semester examination.